Einstein must get rid of this idea of a single universal based clock. And that's no easy task, because think about it. We live in a universe that has this forward arrow of time. Einstein needs that to go away and make our own personal clocks the only thing that matters. So how is he going to do this? And you guessed it. He is going to use Poincare's idea of using light signals to create this synchronous time between two clocks. Now, these two clocks are separated by some amount of space. A light pulse is then bounced back and forth between these two clocks, and that allows them to adjust to a common time between the two clocks. Now, it's very important to note that clocks that are adjusted this way need to be stationary. In Einstein's paper, he's going to start moving these targets and try to convince us that he has discovered something new in physics called relative simultaneity. And one last Poincare reference, he wrote a paper called The Measure of Time, and this is the trick that Einstein is going to use. The idea of simultaneous events and how we measure them using time. So let's start digging into Einstein's paper and look at his light clock synchronization procedure. It is defined in section 1 of his paper and is similar to an 8th grade math word problem. Here he has a very simple definition of time, and it's the position of the hands on a watch. Now let's look at a simple animation that demonstrates this statement of synchronization of clocks, and we'll better understand what this equation means. We have two stationary clock towers, one at point A and another one at point B. At time TA, we're going to send a light pulse to the second clock tower. It arrives at the second clock tower at time TB. So the first half of the cycle is complete, and let's assume that it took 1 second, so the time it arrived at TB is 1 second. It started at TA at obviously 0 seconds. So we have 1 second total for the first half cycle. Now, the light pulse gets reflected from this clock tower at time TB. It arrives back at the origin at time T prime A. Now we have the full equation. The reflection back started at 1 second and arrived at the origin at 2 seconds. So we have 2 minus 1 is 1. 1 second equals 1 second, and we have synchronized clocks. But remember, this whole procedure of synchronizing the clocks and defining simultaneousness requires stationary clocks for the light pulse to bounce between. And again, with Poincare, the timepieces are then adjusted. They mark the same hour at the same physical instant, but on one condition, which is that the two stations are fixed. Okay, I think I've made my point. Let's read this sentence, and it should match the animation we just went through. Let a ray of light start at the time TA from point A towards point B. Let it at the time TB be reflected at point B in the direction of point A, and arrive again at point A at the time T prime A. It's a very simple word problem, and it gives us this time interval and this time interval. If they're equal to each other, then we have this definition of synchronism. And these synchronous stationary clocks give us the definition of simultaneous. It's very important to understand the clock sync method because Einstein is going to use this to try to convince you that the moving clock is a real time and not just an apparent time. Now, before we leave section 1, let's take a closer look at this equation. Einstein creates a different form of the equation we just learned. This one is in distance, rate, and time. And this is the full cycle of the light bouncing back and forth. And down here, I have the same equation written as 2 half cycles. This half cycle format is what he uses in section 2. And it's still distance, rate, and time. This is the previous slide equation, and these time intervals are equivalent because we had the fixed clock tower distances and the fixed speed of light. Just for fun, let's see what this equation would look like if the speed of light was not constant. So we could just simply subtract a velocity from the speed of light, and on this first half cycle, the light pulse would just move slower. And then on the way back, we could add a velocity and it would come back faster. Then obviously, time interval 1 would not equal time interval 2. Now, where am I going with this? In section 2, he is using these 2 half-cycle equations. We have our time intervals, we have our fixed distances, but look at this. He is changing the rate or the speed of light. So what the heck is Einstein doing here? He says, taking into consideration the principle of the constancy of the velocity of light, and then down here in each half cycle, he's changing the constant velocity of light. That's just too obvious of a mistake. There must be something more to the story about these distances and rates in these equations. So now we move on to section 2 and the rigid rod word problem. So now we have the stationary rigid rod, and it is going to move with velocity v along the x-axis. It's very simple. We basically took one of the clock towers and turned it horizontally, and then it's going to move in that direction. Now this should look very familiar to you. Let a ray of light depart from point A at time ta, let it be reflected at point B at time tb, and reach point A again at time t prime a. Now let's look at the animation. The velocity will be imparted to the rod and the light pulse will leave point A. Now we are at point B and it will get reflected back to point A. So with the velocity of light being constant, it's obvious that this time interval is going to take longer than this time interval. So it's no secret that these time intervals are not going to equal each other. That makes perfect sense because the only thing that's changed is the distances that we are measuring. So basically, Einstein is just moving those stationary clock towers. Since these time intervals do not equal each other, Einstein is then concluding that we cannot attach any absolute significance to the concept of simultaneity. 2 events which are simultaneous can no longer be looked upon as simultaneous events from a system which is in motion. So, do you really think that Einstein has discovered new physics that overturns the universal forward arrow of time just because of a distance change in a distance equals rate times time equation? We've got to dig into this a bit further. This little section is where Einstein is trying to prove that relative simultaneity is a real thing. And if Einstein is correct, then this is the exact spot where he gets to change the moving clock from an apparent time to another real true time. So back to this scenario, if we didn't stop the light pulse at rod point A, it's easy to see that we would have the light pulse going back to the origin. It would give us equal timing for each half cycle. So then why is Einstein stopping the light pulse right here and giving us a shortened time t prime a? Now I think we can see why the rate in these equations is not equal to the speed of light. RAB is the length of the moving rod, and it looks like the distance in these equations are equal because of that variable. So if we assume the constant speed of light in these equations, then the velocity term really represents a distance change. But there's no new scientific revelation here. If something is traveling at a constant speed, but it goes a different distance in one direction than the other direction, obviously the time intervals are going to be different. Let's look at more details within Einstein's word problem to see if we can figure out how he is convincing the world that the moving clock is a real clock. So now we will add clocks at the two ends of the rod, and they will be synchronized with the stationary system clocks. We will also add a moving observer with each clock. So these clocks on the moving rod are synchronous with the stationary clocks. But wait a second, we have moving clocks that are staying synchronous with stationary clocks. Moving clocks are supposed to slow in relativity, but these two moving clocks correspond at any instant to the time of the stationary system at the places where they happen to be. These moving clocks are therefore synchronous in the stationary system. That's pretty clear. These moving clocks do not slow. This to me sounds a lot like the moving time equals stationary time, which is the exact opposite of what Einstein relativity is about. So then we have the moving observers next to each clock. Then these observers apply the clock sync method from section 1 to synchronize these clocks. Now wait a second. We know that the section 1 method was designed for stationary clocks. When we apply it to moving clocks, it's obvious that it is going to desynchronize these clocks. And then we continue the word problem down to the equations. And then this is Einstein's big revelation. With the faulty method of trying to synchronize clocks on the move, we then cannot attach any absolute significance to the concept of simultaneity. Yeah, right. So here is a big contradiction in this paper. The observers in motion that are trying to synchronize their clocks will have this time interval not equal to this time interval. To illustrate this again, we have the light pulse from the first clock sent to the second clock. And this is the first time interval. And now it bounces back to the first clock. And then we have the second time interval. And these two intervals obviously do not match. But when we move into section 3, Einstein is going to derive the math for the theory. The moving system is called lowercase k, so let's take a look at what he does there. So from the moving system, lowercase k, and this part should look very familiar, a ray is emitted at time tau 0. Now tau is the moving clock, along the x-axis to x prime. He's using the origin, which would have been point A, and x prime, which would have been point B. And at the time tau 1, be reflected back to the origin, arriving at time tau 2. Same procedure, a little bit different form of an equation, and applied to the clocks of the moving system. So remember from section 1, we have this equation applied to a stationary system. And I just showed you from section 3 with the moving system lowercase k, we get this equation. These equations are equivalent. Let me show you. The subscripts are just changed and T2 is there instead of T prime A. We just take this equation and quickly rebalance it. We add the T1 to both sides and we get 2T1. We add T0 to both sides and we get T2 plus T0. And then we divide out the 2 from both sides and we get an equivalent equation just with some simple rearrangement. Now he just got done telling us that the moving system will not have synchronized timing. This is what we just got done discussing. In section 2, observers in the moving system find that the 2 clocks don't run synchronously, and we get this time interval not equal to this time interval. But for some reason in this moving system, the time intervals equal each other. That's a blatant contradiction. Okay, so here we have Einstein playing both sides of the fence again. We have one thing, which is the moving system clocks, but getting 2 opposite answers: synchronization and desynchronization. Now let's go back and discuss Einstein's very important conclusion. His entire theory of relativity hinges upon this statement, but it's just not correct. So Einstein's purpose of this no absolute simultaneity, or relativity of simultaneity, is to convince you that both answers are correct, even though the moving observer and the stationary observer have 2 different answers. His idea is that both answers are correct. This is what you will hear when you listen to people teaching Einstein's ideas.
So the big question is, who is right and who is wrong? And the answer is, they are both right.
No, they are not, and let me explain that to you. Here we are going to modify the moving rod scenario that you're already familiar with. We have 2 light sources that will simultaneously flash. We are replacing the rod with a bomb. Instead of clocks on each end, we have these light-based triggers. If the light simultaneously hits these triggers, then the bomb will explode. If we have a moving target, then the light will not hit the triggers simultaneously simply because of a distance change. Absolutely every time the stationary system is going to see a simultaneous event occur. And absolutely every time this moving bomb will never see those same 2 flashes as being simultaneous. So Einstein is trying to use this idea to convince you that both answers are correct, when in reality, the moving bomb always sees a non-simultaneous event because he doesn't explode. The moving bomb is just always wrong. Obviously, because the stationary bomb exploded, and it always explodes because of this simultaneous event. Let's apply this concept to physical reality. So from the previous video, this person can bet all day long that the source trumpet is making an F-sharp tone. He's just always wrong. I mean, sure, the F-sharp is actually what he is hearing, but we know exactly why it is, and it's because of the Doppler effect. Einstein wants you to believe that both of these answers are equally valid or equally correct. But in reality, one of these answers is always going to be actually physically incorrect about what the source is doing. So this is the real meaning behind this very important section of Einstein's paper. It's not that both answers are equally valid or equally correct like he wants you to think, but rather one of these frames is just going to have an incorrect answer about what is actually going on at the source. Now, if you're still a believer in this idea of relative simultaneity, in section 3, this is where it gets put to the test. And this test is called the spherical wave proof. The purpose of this proof is to show that the second postulate of the constant velocity of light is compatible with the first postulate of the principle of relativity. The second postulate is really just about the transformation math from Voigt. You can just think of this as, are Voigt's equations compatible with the principle of relativity? Einstein had to pull this trick in section 3 because this is the exact assumption that Voigt's transformation math makes. So let's demonstrate what this spherical wave proof looks like. We have a moving frame that will move past the stationary coordinate of 0, 0. When that occurs, a single light pulse will be created by the stationary observer. So like I said, when the origin of the coordinates is common to both of the systems, let a spherical wave be emitted therefrom and be propagated with the velocity c in the stationary system. Let's say that the moving frame is moving at 95% of the speed of light. It would look something like this. And we'll go ahead and stop this at 1 second, or at 1 light second. So at this point, we can refer back to the spherical wave proof program I wrote in Python. We have the stationary spherical wave. When those spherical coordinates are transformed using the math equations, we get this Doppler-like looking ellipse. Someone that believes in relative simultaneity would tell you that you get that ellipsoid because you plotted out all of these different moving times or moving taus, and you can't do that. Instead, you have to line up the tau coordinates and draw a circle around this moving frame, which is obviously what Einstein wants to convince you of. He says, the wave under consideration is therefore no less a spherical wave with the velocity of propagation c when viewed in the moving system. So here goes 1 equals 2 physics. Somehow, if this is to maintain a circle around it in every tick, it must have cloned the stationary light wave, and it is dragging its own circle along with it as it is moving away from the 0, 0 coordinate. So think about this. What is the physical reality of this moving frame maintaining a perfectly centered circle around itself? I mean, it's moving away from the original stationary light pulse. It's just fantasy physics where a single light pulse gets cloned into the moving frame and magically maintains its own perfect circle on the move. So relative simultaneity is 1 equals 2 fantasy physics, and let's tie this back to the original debunking video I did. Einstein would say that both of these scenarios are equally valid at the same time. In reality, they're just two different scenarios that need to be treated separately. With the boxcar at rest, you're going to get this answer. This answer just means that the light pulse originated inside the boxcar. There will be no Doppler shift in the light for people moving within this boxcar. The people on the outside will just experience Doppler shift of the light, and they won't be very good at judging whether or not the light pulses simultaneously hit each side of the boxcar. they'll just be wrong compared to the people that are moving along with the light source. With the pole at rest, you're going to get a different answer. So in this case, the light source originated outside of the boxcar. The people standing outside would not notice a Doppler shift. The people inside the boxcar would notice a Doppler shift in the light, and they would be poor judges of simultaneity of this light pulse. And we are done. So unlike Einstein, I am going to show you all of my main sources that I used in order to help reteach this information. In this particular video, this person on YouTube is where I stole the bomb idea and learned how to walk through this relative simultaneity failure. Hopefully through this video series you have a better understanding of Einstein's confusion with his theory of relativity. And thanks for watching.